Now briefly, and go back to the videos that I posted. Something moved around the circle. We have three vectors. We have the R vector. It's an R of t, but for labeling purposes, I'm going to keep the labeling brief. And I had colors for these things. I don't remember what color I used for which, but you have a velocity. And you have now your centripetal acceleration, which presumably you understand better than you did before. Okay? And you have try to make a small theta that doesn't interfere with that R, which I'm sure thought through. You know, put the T values there on theta. And now that's in the way, but we're just going to have to live with it. Okay? So you have these three vectors. And let me put theta down here. I'm not going to put the T dependence because that will allow me to label this a little better. I really should think that through before I start labeling it. I never do. Okay. So what you have x of t, and you have y of t. Those are vectors. Okay? The end of the x of t vector, all the, these vectors, the r and the x and the y vectors, have initial point at the origin, and the end point is out here, okay, this point. Now, r of t, and let's say we have radius a, and it doesn't have an arrow over it, just a radius, okay? So it's not a vector, but I use an arrow to indicate it. Actually, I could probably use a double-edged arrow, which is clearly not a vector, and remove all ambiguity. Okay, so we have r. R of t is cosine of theta of t times I. You know what the I vector is? I said it. It's a vector of magnitude 1 in the positive x direction. Okay? And it's a times that. Put that on. And that's just from the definitions of the sine and cosine, which are defined in terms of a circular function. In terms of the unit circle. Sorry, John?
The I vector is what?
It's a unit vector, a vector of magnitude 1 in the x direction. So here. I just make it horizontal to understand what it's supposed to do. There's your I vector, there's your J vector. So cosine theta times I is a vector whose magnitude is the cosine of theta and whose direction is the direction of I.
I wasn't sure if you were writing I's and J's on the videos, on the chalkboards. They're very similar.
You tell my I's from my J's and one
You're
curls
also
this way,
similar
one
I's
curls
and
this way.
J's.
But,
I thought they were all I's.
it might be a little subtle. I'll have to look at the
First one was
videos.
clear, but everything after you see.
Sorry?
The first example looked like a J. Everything after seemed like a bunch of I's.
Okay, well, sometimes, J arcs this
I got
way,
it.
I arcs this way,
All right.
and I don't think I make them straight. Okay? But, the chalk can sometimes confound me. But I'm usually, in the habit of making that, but that's the difference. And if you don't pick up on that, or if I don't write them as clearly as I think I would.
I agree.
something that does need clarification. Good. Okay? So anyhow, that's it. So what's your velocity? You know. I'm not going to write it out again. Because you're both competent at doing these derivatives, okay? Now, if theta of t equals omega t or omega t plus phi, makes no difference. The derivatives are simple. Simple enough. If theta is not a linear function of t, then your theta prime is going to be a little more complicated, right? And of course, every time you take a derivative, the chain rule says you got to take the derivative of theta and multiply it by the derivative of what you got here. Okay? If theta is a linear function of t, where the linear part has coefficient omega, the linear term has coefficient omega, then you're just going to get an omega. So R prime of t is just going to be an omega A because each of these has an omega t inside, right? Well, you can figure out what goes in there, okay? The second derivative is more complicated because now you have a product function. This is all a function of t, this is a function of t, you got to use the product rule, right? So that's going to be theta double prime of t times a times what we have here, okay? That's going to be theta prime of t, a, times the derivative of whatever we have here. So, I'll put green parentheses around this term to indicate whatever's in parentheses is what you got here, right? Then you do the derivatives. It makes sense of what I just said. You got to be careful about the chain rule. However, if theta omega t plus phi, theta double prime is 0, so you don't have this term.
I don't have it, my cousin did.
And theta prime is just omega,
It's obviously a contract with
okay?
you're gonna. Oh, it's not.
And this prime gives you another omega. And then you end up with your equations of simple harmonic motion as well as equations of the motion of this thing and equations for the velocity and the acceleration. If omega is constant, this term is non-existent. And what you end up with when you take the derivative of this is just a negative of what you have here. Which leads us to another form of the equation for the formula for centripetal force. Centripetal acceleration, which leads to centripetal force. Okay? Okay, well, that's enough fun with that. See if you can nail those problems for Monday. There are only 3 of them. They're not that hard once you understand it. It's just pretty straightforward. But, you know, all the concepts behind it take some sorting out.